Configure NAT for IPv4. Network address translation for IPv4. This topology. Packet tracer 4321 routers, 2960 switches, 2 PCs, S2, S1, R1, R2. Between routers, gigabit 00 on both sides. Between switches, fast Ethernet 1 on both sides. From router R1, gigabit 001 to fast Ethernet 5. From S2 fast Ethernet 18 to PCB. And from S1 fast Ethernet 6 to PCA. Addressing table. Required resources on real lab. 2 routers, 4221, 2 switches, 2960, 2 PCs, console cables, Ethernet cables. Build the network, cable the network. Already done. Configure basic settings for each router. These configurations were made in another labs for security and basic settings, and for me it's optional. I will only configure the device name, the IP addressing, and the default route. Okay, and configure routers R1 to interfaces. Okay, R1. No, enable configure terminal. Don't forget the host name, R1, interface, gigabit 000, IP address 209.165.200.230. Subnet mask 248. No shutdown. And gigabit 001, IP address 192.168.1.1, subnet mask 24. No shutdown. Okay. Now on gigabit 00 side, you have this IP address. On gigabit 00 side, you will have this network address 209.165.200. 234 prefix 29. Okay. Okay, on this side, this network address. Internet service provider has allocated the public IP address space of 209.165.200.224 prefix 29 to a company. This network is used to address the link between ISP router R2 and the company gateway R1. Okay, so R2 is simulating the internet service provider, the ISP. Okay, and R1 is the company router. Okay, in the another side, you will have on gigabit 001, you will have this address. The network is 192.168.1.0 prefix 24. Very good. Now configure R2. Command line interface. Now enable configure terminal hostname R2, uppercase R2, interface gigabit 000, IP address 209.165.200.225, subnet mask 248, that is 29 prefix. Enter. No shutdown. Very good. And okay, this is the on gigabit 00 side. You will have this network, but also configure a loopback 1 interface. Okay, a loopback 1 here. R2 interface loopback 1. Enter IP address 209.165.201, prefix 224. Very good. Configure a default route to R2 from R1. Okay, on R1, configure default route, exit. On global configuration mode IP route, the default route is this. And for R1, the NAT hub IP address is the IP address of gigabit 000 on R2. And the IP address of gigabit 00 on R2 is 225, 209.165, 200, 225. 209.165, 200, 225. Enter. Very good. Now I recommend to configure PCs now. Configure PCA and PCB. PCA 192.168.1.2, prefix subnet mask 24, and default gateway 192.168.1.1. Okay, this is the default gateway. Gigabit 001 on R1. Gigabit 001 on R1. 1.1. Okay, now configure PCB 192.168.1.3. 24, 192.168.1.1. Okay, for example, from PCB, verify the IP address on command prompt, ipconfig, and ping the default gateway. From PCB, ping R1. Okay, ping 192.168.1.1. Enter. Success. Very good. And now try to ping R2. Gigabit 000 on R2. Okay, gigabit 00 on R2 is 209.165, 200, 225. Ping 209.165, 200, 225. Enter. Okay, ping fails. Okay, so that's why you will configure NAT, network address translation. Also, if you want from PCB ping to loopback 1, also ping fails. Okay. Okay, ping fails. And don't forget to configure basic settings for each switch. These configurations were made in another labs for security and also for basic settings, but I will only configure the device name and interface IP addressing. Okay, go to S1, on VLAN 1, go to S1, command line interface, enter, enable configure terminal hostname S1, interface VLAN 1, IP address 192.168.1.11, subnet mask 24, no shutdown, exit. On global configuration mode, IP default gateway dash gateway 192.168.1.1. The same gateway of the PCs. Okay, S2. Command line interface, enter, enable, configure, terminal, hostname, S2, interface, VLAN 1, IP address, 192.168.1.12, subnet mask 24. Okay, this IP address on VLAN 1, 112.24, on VLAN 1, 112.24. Enter, no, shutdown, exit, and on global configuration mode, IP space default gateway 192.168.1.1. Okay, default gateway, enter, very good. Configure and verify NAT for IPv4, network address translation for IPv4. Configure NAT on R1 using a pool of 3 addresses, 209.165.200, 226, 209.165.200, 228. Okay, 226, 227, and 228, 3 addresses. Okay, and if this is the network address, here there is a range of addresses. For example, the range of addresses goes on this network. The range of host addresses, available host addresses on this network is the following. The following range: 225.225 to that 230. Okay, this is the range. Okay. R1 already uses 230. R1 uses 230. 230 in use, and R2 225 already in use. Okay. R2 225. Okay, but and here on this range 225 in use, 226 available, 227 available, 228 available, and 229 available, 230 in use. Okay. Configure simple access list that defines what hosts are going to be allowed for translation. In this case, all devices on the R1 LAN. Okay, all devices on this LAN, this network address 192.168.1.0 prefix 24. And this is the access list. On R1, create the access list on global configuration mode, access-list number 1. Permit 192.168.1.0, and the wildcard for 24 is this. Very good. Create a NAT pool and give it a name and a range of addresses. Okay, IP NAT pool, the name public underscore access. Okay, public underscore access. No spaces. And now the range. Okay, the range. Okay, the range is from 226 to 228. Okay, so for NAT, you will use for the pool NAT, for the NAT pool, you will use from 226 to 228. This range. Two of 165, 200, 226, 209, 165, 200, 228. This range. 3 addresses, 226, 227, and 228. And NAT mask. What NAT mask to use? NAT mask this NAT mask, 29. Okay, and 29 in decimal is 248. To 55, to 55, to 55, to 48. Enter. Very good. The NAT mask parameter is not an IP address delimiter. It should be the correct subnet mask for the addresses being assigned, even if you are not using all the subnet addresses in the pool. Configure the translation, associating the access list and pool to the translation process. Okay, IP NAT inside source list number 1. Okay, list number 1 is this list number 1, and the pool public underscore access. Okay, the pool is this pool. Okay, sensitive, and that's it. Enter. First, word inside is critical to the operation of this kind of NAT. If you omit it, NAT will not work. Second, the list number is the access list number configured in a previous step. Third, the pool name is case sensitive. Define the inside interface. Gigabit 001 is the inside interface. Gigabit 001 is the inside interface because this is the internal LAN, the local area network. Okay, interface gigabit 00001, IP NAT inside, enter. And outside interface gigabit 000, the interface facing the internet service provider. Okay, gigabit 00, gigabit 000, IP NAT outside. Very good. Now test and verify. From PCB, ping the loopback interface 209.165.201 on R2. Okay, PCB, ping 209.165.201. Okay, from PCB, ping loopback 1 on R2. Enter. Success. Okay, on R1 and show IP NAT translation. Okay, the protocol is ICMP. The inside local is 192.168.1.3 is the IP address of PCB, and the port is number 10. Okay, this. And the inside global 209.165.200.226, and the port is number 10. This IP address, the first IP on the pool 226. First IP on the pool 226. Okay, the first IP on the pool. Outside local, on both cases, 209.165.200.1 port 10. Outside local and outside global, 209.165.200.1 port 10. Loopback 1. Okay, very good. What was the inside local address of PCB translated to? Okay, inside local address, this was translated to the inside global 209.165.200.226. This is the answer. 209.165.200.226. What type of NAT address is the translated address? The inside global, the translated address. From PCA, ping loopback 1 interface on R2, 209.165.200.1. Go to PCA. Ping 209.165.200.1. Success. Verify again on R1, show IP NAT translation. And now you will see 192.168.1.2 is translated. Okay, on a real device, real network, you will see that PCB is translated to 226 and PCA is translated to the second IP in the NAT pool, 227. Okay, for example, I will try to do the following. From PCB ping and from PCA ping both to the default to the loopback interface to R2. Okay, and show IP NAT translation. And now, if both pings were made at the same time, okay, PCA 192.168.1.2 is translated to 209.165.200.226, the first IP address in the NAT pool, and 192.168.1.3, the IP address of PCB is translated to 209.165.200.227. Okay, the second IP address in the NAT pool. Okay, very good. Okay, notice that the previous translation for PCB is still in the table. From S1, ping the loopback interface on R2, 209.165.200.1. Okay, from S1, enter, enable, ping 209.165.200.1. Okay, success. Now, try the ping again from the PCB, ping loopback, enter, PCA, loopback, enter, and go to S1, ping to loopback, enter, and go to R1, show IP NAT translation. And now you will see the following. PCA 192.168.1.2 is translated to 226. S1 192.168.1.11 is translated to 227. And PCB 192.168.1.3 is translated to 228. Okay, so 226, 227, and 228 in the NAT pool are in use. Very good. Okay, 227, 226, 228. Now try and ping R2 loopback 1 from S2. This time the translation failed and you get the message or similar on the R1 console. Okay, from S2, enter, enable, ping 209.165.200.1. From S2, ping loopback 1 on R2, enter, success. Okay, PCB, enter, PCA, enter, S1, enter, S2, enter. Okay, all pings. Okay, S1 is failing. Okay, S2, success, PCB, success, PCA, success, but S1 fails. Verify on R1, show IP NAT translation. Okay, 12 is S2. 1.12 is S2 switch, is translated to 226. Okay, 1.3 is PCB translated to 227, PCA translated to 228. But S1 was not translated because there are only 3 addresses in the pool: 226, 227, and 228. 226, 227, and 228. So you can translate three devices: PCB, PCA, and S2. But S1 was not possible. But S1 is not translated because you need an additional IP address here, and you got only 3. Okay, verify again. PCB, ping, PCA, ping, S1, ping, S2, ping. Okay, and S2 will fail. Okay, S2 will fail because it's the 4th device. Show IP NAT translations on R1. Okay, but on real device you will get this message: NAT address allocation failure. Address allocation failed. Pool 1 may be exhausted. Very good. This is an expected result because only 3 addresses are allocated, and we tried to ping loopback 1 from 4 devices. Recall that NAT is a one-to-one translation. So how long are the translations allocated? Issue the command show IP NAT translation verbose, and you will see that the answer is for 24 hours. Show IP NAT translation verbose. Enter. Okay, verbose. Enter. Okay, Packet Tracer does not support this command, but on a real device, and on a real device, you will see the timeout that is counting from 24 to 0, from 24 hours to 0. Given the pool is limited to 3 addresses, NAT to a pool of addresses is not adequate for our application. Clear the NAT translations and statistics, and we will move to path. Clear IP NAT translations and enter. Okay, clear IP NAT translation. Okay, and this symbol and enter. Very good. Clear IP NAT statistics. Okay, on R1, clear IP NAT statistics. Okay, Packet Tracer does not support this command. And don't worry about this. Configure and verify path for IPv4 port address translation. You will configure replace NAT with path to a pool of addresses, and then with path using an interface. Remove the translation command on R1. The components of an address translation configuration are basically the same. Something, an access list to identify addresses eligible to be translated, an optionally configured pool of addresses to translate them to, and the commands necessary to identify the inside and outside interfaces. From part 1, our access list 1 is still correct for the network scenario, so there is no need to recreate it. We are going to use the same pool of addresses, so there is no need to create that configuration either. Also, The inside and outside interfaces are not changing. To get started in part 3, remove the command that ties the access list and pool together. Okay, remove this command. Go to R1, remove this command. Enter, enable, configure terminal. No IPNAT inside source list 1 pool public underscore access. Okay, pool public access. Enter. Add the path command on R1. Configure for path translation to a pool of addresses. Remember, the access list and pool are already configured, so this is the only command we need to change from NAT to path. Okay, use this. IPNAT inside source list number 1, the pool public underscore access. Okay, the keyword overloads. Okay, for port address translation. Enter. Test and verify. Let's verify path is working. From PCB, ping loopback 1 interface 209.165.201 on R2. Okay, from PCB, ping loopback interface on R2. From PCB, ping loopback on R2. Success, go to R1 and show IP NAT translation. Enter. Now, the inside local PCB 192.168.1.3 and the inside global, the translation is to 227. Okay, the second IP and the NAT pool. Remember, the first is 226, the second 227, and the last 228. What was the inside local address of PCB translated to? In my case, 227, 209.165.200.227. What type of NAT address is the translated address? Inside global, the translated address. Okay, for example, from PCB, ping the loopback. From PCA, ping the loopback. From S1, enable ping 209.165.201, ping the loopback, and from S2, enable ping 209.165.201. Okay, all pings successful. PCB, PCA success, S1 success, and S2 success. Show IP NAT translations from R1 space, and you will see all translations. Okay, for example, this is 192.168.1.11 is S1 is translated to 227, port 21 on and port 1024. 192.168.1.12, this is S2. This is S2, switch 2. Port 16 is translated to 209.165.200.227, also uses port 16. This is PCA 192.168.1.2, port 21, translated also to use 227, port 21. And this is PCB 192.168.13 port 33 is translated to 227, also using port 33. Okay, what is different about the output of the show IP NAT translations command from the NAT exercise? There is no dedicated translation between an inside and outside address listed. All inside local addresses can be translated to use only one inside global address. From PCA, ping loopback1 interface 209.165.201 on R2. Okay, from PCA, ping loopback interface on R2. Enter success. On R1, show IP NAT translations. Show IP NAT translation. Okay, you can see this. Notice that there is only one translation, and again, send the ping once more and quickly go back to the router and issue the command show IP NAT translations verbose, and you will see what happened. Okay, ping again on PCA, ping loopback, and go show IP NAT translation verbose. Okay, Packet Tracer does not support this command. And you can see on real app or emulator like GNS3 or any other, the translation timeout has been dropped from 24 hours to 1 minute. And that means on port address translation path, the timeout is 1 minute. Generate traffic from multiple devices to observe port address translation. On PCA and PCB, use the T parameter with the ping command and send non-stop ping to R2's loopback interface. Ping option T to 209.165.201, then go back to R1 and issue the show IP NAT translation command. Okay, for example, PCA ping, use the option T. Okay, it's a continuous ping. Okay, PCB ping. Okay, 200.1, the loopback interface, option T. Okay, PCA, PCB, R1, show IP NAT translations. I'm sorry, show IP NAT translation. You will see all the translations. But all the translation uses, for example, 192.168.13 is PCB translated to 227. 192.168.12 PCA translated also to 227. Okay, go to PCA, Control C to stop. Go to PCB, Control C to stop. Notice that the inside global address is the same for both sessions. Okay, for both sessions, the inside global is the same. 227 in my case. How does the router keep track of what replies go where? Unique port numbers are assigned. Okay, for example, the port is different. Okay, each port is different, so that's why it's called port address translation. Okay, each port is different. Okay, very good. Path to a pool is very effective solution for a small to mid-size organization. However, there are unused IPv4 addresses involved in this scenario. We will move to path with interface overload to eliminate this waste of IPv4 addresses. Stop the pings on PCA and PCB within the Control-C key combination, then clear translations and translation statistics. Okay, on R1, clear IP NAT translation, and this symbol, clear IP NAT statistics. Enter. Okay, Packet Tracer does not support this command. But don't worry about this. On R1, remove the NAT pool translation commands. Once again, our access list 1 is still correct for the network scenario, so there is no need to create it. Also, the inside and outside interfaces are not changing. To get started with port address translation to an interface, clean up the configuration by removing the NAT pool and the command that ties the access list and pool together. Remove two commands. Okay, the association of the access list and pool and the pool. Configure terminal. No IP NAT inside source list 1. The pool is called public access using overload. Public underscore access using overload. Enter. And remove the pool. No IP NAT pool public underscore access. Okay. Very good. Enter. Add the path overload command by specifying the outside interface. The outside interface on R1 is gigabit 000, so that's why IP NAT inside source list, access list 1, interface gigabit 00 overload. IP NAT inside source list 1, interface gigabit 000 overload. Enter. And that's it. Test and verify the configuration. Okay, remember what is the IP address of gigabit 00 is on R1 gigabit 00 209.165.200 Remember 230. Test and verify the configuration. Let's verify path to the interface is working. From PCB ping loopback 1 interface 209.165.201 on R2. Okay, from PCB ping loopback on R2. Okay, now option T 209.165.201. Enter. Success. On R1 verify and show IP NAT translation. Enter. Now you will see this is the inside local 192.168.1.3 is PCB and is translated to 209.165.200.230, the IP address of gigabit 00 on R1 230. Okay, and obviously if uses overload uses port address translation and the port is different. Generate traffic from multiple devices, observe path. On PCA and PCB, use the T parameter with the ping command and send a non-stop ping to R2's loopback 1 interface. On S1 and S2, use the privilege exit command ping 209.165.201 and repeat 2000 times. Okay, PCB, use the option T. PCA, use the option T, ping with option T. S1, enter, enable config ping 209.165.200.1 and repeat 2000. Enter. Okay. Pocket Tracer does not support this command, but you can use a simple ping on S2, simple ping, enable ping 209.165.200.1 success, PCB Control C, PCA Control C. Okay, Control C to stop the processes. PCA stop ping. Okay, ping successful from PCA, from PCB success, from S2 success, from S1 success. R1 show IP NAT translation, and you can see all translations. 192.168.1.3 is PCB translated to 230. 192.168.1.2 PCA translated to 230. Okay. 192.168.1.12 translated to 230. This is S2. And 192.168.1.11 S1 translated to 230. And ports are different. Now, all the ENSA global addresses are mapped to gigabit 00 interface IP address. Stop all the pings using Ctrl-C key combination. Configure and verify a static NAT for IPv4. You will configure a static NAT so that PCA is directly reachable from the internet. Okay, PCA will be reachable from internet. PCA will be reachable from R2 via address 209.165.200.229. Okay, remember this is the range for this network. If you have this network address on this section, on this connection, this is the range of available host addresses. And the NAT pool uses from 226 to 228. 225 in use, 230 in use, 226 in use, 227 in use, 228 in use, and only one IP is available, 229. Okay, 229, that 229. And you will configure the static NAT for this and will be redirected to PCA. Okay, here. Very good. The configuration you are about to complete does not follow recommended practices for internet-connected gateways. This lab completely omits what would be the standard security practices to focus on successful configuration of static NAT. In a production environment, careful coordination between the network infrastructure and security teams would be fundamental to supporting this requirement. On R1, clear current translation and statistics. R1, clear IP NAT translation in this symbol, enter. Clear IP NAT statistics, enter. Okay, Pocket Tracer does not support this command, and don't worry about this. Configure NAT command required to statically map an inside address to outside address. Configure static mapping between 192.168.1.11 and 209.165. Okay, this should be 2. Okay, this should be 2. Okay, because it's on go to PCA, ipconfig 192.168.1.2. Okay, configure static mapping between 192.168.1.2 and 209.165.201 using the following command. Okay, the inside local and then the inside global. Go to R1, enter. Configure terminal. IP NAT inside source is static. Inside local 192.168.1.2 is PCA IP address. Inside global 209.165, 200, 229. Okay, this. Enter. Test. Let's verify the static NAT is working. On R1, display the NAT table on R1 with the command show IP NAT translations. Okay, and you should see the static mapping. Okay, on R1 and show IP NAT translation. And this is the static mapping. Okay, the inside local statically mapped to inside global 229. The translation table shows the static translation is in effect. Verify this by pinning from R2 to 209.165, 200, 229. The pings should work. R2, enter, enable ping 209.165, 200, 229. Ping to the inside global, enter. Success. On R1, verify. Show IP NAT translations. And you will see now the inside global 209.165, 200, 229 is translated to inside local 192.168.1.2. And the outside local is 225. 225 is the IP address of gigabit 00 on R2. This IP address, 225. Okay, on both cases, outside local and outside global is 225. But inside local, IP address of PCA, and inside global, 229. Okay, you may have to disable PC firewall for pings to work on Windows PCs on real lab. This validates that the static NAT is working. Thank you very much.